For our penultimate section this semester, we are going to look at measures of central tendency. Very highfalutin notation there. Really what we're talking about are averages. We're trying to see what happens for our data set, what the stuff will tend towards. If we pull something from out of the set, about what should it be? And we have four big ways to look at this, where the first we're going to see is what's called the mean, where the mean is what you think of probably when you first imagine an average. It's sometimes called the arithmetic average. What we do there is we take all of our values, we sum them up, and we divide by the number of values. So we use this notation here with that capital sigma, means take the sum of all of those things, and then divide by n, where we denote this with x bar. And I'll mention that for reference, this is the sample mean, to be specific. In a stats class, you'll also see you have a value called the population mean, which is denoted with the Greek letter mu, and in general, we use Greek letters for population parameters and English letters with accents for sample statistics. We're mostly just going to focus on the statistics here in this class with a quick pickup of some of the topics. But anyway, what we should do with this is get an example to see how these things run, as it were. So let's say that a surveyor collected the heights of a class of third graders at the zoo with the data as follows in inches. And what we want to do here is compute the mean for this data set. So, the process is something we've probably done before, just haven't thought of it maybe in these terms, at least not in a while. And I think that these guys should be things you've done in the past at some point, if not in the stats class. And I remember doing this stuff in elementary school, but I can't speak for everyone. Anyway, we get x bar here is going to be the sum of all of those heights, 43 plus 44 plus 44. I have these in ascending order for no particular reason, but I'm going to take those and then put an ellipsis in there to make space and save time. 54, and finally that very strange value that should have stuck out to you when you saw it in the list of 168 inches, where we take all of these values, add them up, and divide by the number of values, which here is 9 third graders. It's a small class, which gives us a mean of 60.2 inches, which tells us that the average height of third graders is 5 feet tall. It's a bit dubious. I don't think I knew any fifth graders who were 5 feet tall. Well, maybe one. But the issue here is that our surveyors have to be an opportunistic people to make their work. And he was a bit in a rush to get those values. Ended up getting the height of a giraffe in with those third graders when we went to the zoo. Not very good statistickery. There's a better word for that, but I can't think of it offhand. Anyway, the point of this is to show that while the mean is a nice value for central tendency, a nice value for averageness, it's very susceptible to unusual data points, things called outliers that we won't technically quantify in this class, but you can think of as being unusually large or unusually small values. In this case, the height of the giraffe of 168 inches is unusually large for a third grader. So it caused our mean to be brought up.